In this video, we're going to discuss confidence intervals for the standard deviation and variance using the chi-square distribution. So first, this symbol here that looks kind of like an X is actually the Greek letter chi. So it's spelled C-H-I, and this notation you read as chi-square, right? Because it's raised to the second power like this. Okay. So we're going to be using the chi-square distribution to construct confidence interval estimates for the standard deviation and variance. So the reason for this is if you imagine taking the sampling distribution, right? So what that means is that imagine you take many different samples of the same size n, and you calculate the statistic for these particular samples. So like either variances or proportions. So previously when we talked about proportions, right? So when you take many samples and you calculate their proportions, and then you sort of plot them in a histogram, it has the shape of the normal distribution. However, that's not the case for the variance and the standard deviation, right? So if you calculate, again, if you take many different samples and you calculate all their different variances and plot them in a histogram, it's going to have this kind of shape here, which is called the chi-square distribution. Okay, so because we're working with a slightly different distribution, here we discuss some of the properties of this distribution. Right, so the first thing we need to take a note of is the degrees of freedom, which is just taking the sample size and then subtracting 1. So the shape of the chi-square distribution depends on the sample size, right? So for small sample sizes, you can see that the shape is very skewed, but for larger sample sizes, the shape is still slightly skewed to the right, but it looks kind of like the normal distribution. And then for very large values of the degrees of freedom, then it gets closer to the normal distribution. Right, so we see that this distribution is not symmetric, but is right skewed, and the shape depends on the degrees of freedom. Okay, so let's take a closer look at the shape of the chi-square distribution. Right, so this is the same picture as before. Right, so as I said previously, what this represents is the sampling distribution. Right, so you imagine trying to take many different samples of size n, and you calculate the variance for all those different samples. They're going to have different values, but if you plot them in a histogram, it's going to form a shape like this. So the idea in the confidence interval is to try to get a range of values that encapsulates most of what these sample variances are going to occur. So the basic setup is going to be the following. Right, so here the entire chi-square distribution has a total area of 1, but when we construct a confidence interval, we fix some particular confidence level, and the confidence level represents where the likely values are going to occur. Right, so the confidence level should contain most of the values, and so it should be the large portion in the middle, and so we cut off a left tail and a right tail, and so the confidence level represents the area in the middle. And typically the parts that we cut off we call alpha, right? And because it's split between a left piece and a right piece, this portion is going to have half of alpha, and this portion is also going to have half of alpha. Okay, so those three pieces together again have a total area of 1. So the area, the area is called alpha over 2 here, and then the area here is called alpha over 2, and the middle area is called the confidence level. And so what we're actually interested in is the chi-square value, right? So the values that occur here, and here, these are what's called the critical values. And because this is not a symmetric graph, we have to separate the left and the right value. So let's call on the one on the left chi-square left, and the one on the right chi-square right. Right, so these are called the critical values. And we're going to use the critical values to construct the confidence interval. So the reason we go through this procedure is because the graphing calculator doesn't have, if this calculator can turn on. Yeah, okay. So this calculator doesn't have a single command to calculate confidence intervals using the, this is for hypothesis testing, but they don't have one for chi-square intervals, right? So here, z interval is for the normal distribution, t interval is for the the t distribution, and then this is for proportions, the normal distribution for proportions. So that there isn't one for the chi-square distribution, so we have to sort of calculate it following this procedure here, right? So we're going to obtain the left and right critical values, and so the way we get the way we get the confidence interval is using the chi-square sample statistic formula, right? So how the sample variance and sample standard, how the sample variance and the population variance is related to the chi-square statistic is using this formula here. And so we're trying to estimate the population variance, right? So we solve for sigma squared, so we just cross multiply this. You get this equation here, and we're more interested in the standard deviation, right? So if I want to solve for sigma, I just take the square root. So you get the square root of n minus 1 s squared over chi squared. Okay, so we're going to take each of these two critical values, plug it into this formula, and then that'll give you the endpoints of the confidence interval to estimate sigma. Right, okay, so we have to be a little bit careful here, right? Because chi-square left is going to be a smaller value, and chi-square right is going to be a bigger value, right? So if you divide by a smaller number, it's actually bigger than if you divide by a bigger number, right? So if I plug chi-square left into this formula, this actually gives me the right endpoint. So to obtain the confidence interval, again, you plug the critical value into this formula, but the left one becomes the right endpoint. And then plugging the right critical value into here gives me the left endpoint. And these are the two endpoints of the confidence interval. Okay, so that's the basic idea. So in the next video, I'll go over this procedure in calculating the critical values and also using them to calculate the confidence interval.